All right. So then I come to your room and I turn off your light. Then you become surprised. Like, how did my robot learn about darkness? How come when I turned off the light, it's like all of a sudden the robot is falling down? Who can tell me the answer?
Well, it won't see the edge.
Pardon?
It won't see the edge.
Yeah, but what business has a robot got to do with even seeing?
Probably you should have also taken pictures of the edges.
Exactly. Exactly. So you should also include pictures of edges and not edges in dim light situations. Do you get a point? So if you want to avoid this situation where it's like mistakenly you have built a robot that is susceptible to darkness, how do you think we can overcome this situation? How do you think we can overcome? So the first one is you need to include data from dim light situations. But what's the other approach? I'm going to call names. KB. No KB. Okay, I'm going to answer you. So the way you can avoid these situations is to maybe use an ultrasound sensor in conjunction with your camera. Then the ultrasound sensor is going to be placed at the bottom part of the robot, okay? Then, so that when it gets off the edge and it goes off the edge a little bit, you will see that the distance that the ultrasound sensor is going to measure is going to increase. Because when the robot is not at the edge, the ultrasound sensor is almost facing, it's almost touching the floor. So the distance there is going to be a very short distance. But if it goes over the edge, maybe if I draw, you'll understand. Can you guys still hear me?
Yeah.
Okay.
Yeah.
So let's say this is your car, your robot car, okay? You have your camera here. That's a very nice camera. And you are using it to take photos. But this time around, you want it to be able to work even if it is in darkness. And you forgot to include pictures in the dark. So what you can do is, you see, when the robot goes over the edge, it's going to look something like this. Like a part of the car is going to go beyond the edge of the table. So if you have an ultrasound here, the distance it will measure now at this point is going to be higher. So if you included such data in the training, then I cannot accidentally make your robot misbehave in the darkness. And the reason I'm saying accidental here is when you were building the robot, you set out and you said, I'm building a robot that can avoid the edge of a table. But you forgot that darkness is part of reality. So you didn't include pictures of it in the dark. So imagine you are doing your PhD, you've worked on this thing for 6 months, and you come to meet me as a professor, you're coming to defend. After all your 6 months hard of work, you've come with your followers, they are happy following you, are coming to wow your professors. Then as evil as I am, I just say, just turn off the light. You turn off the light, then you see your robot, the stomach is facing the heavens because you forgot to include light. So I'm sharing this with you so that you understand what is known as biases. So the thing about self-driving car, more likely to knock a black guy than a white guy, is never intentional. You see, when they set out to build it, nobody has time to say, how many pictures are we using that includes Black people, how many are white people? The vision is we want to build a self-driving car. The data available is what we use. And these things are being built in predominantly white countries. So even if you put a camera on the car and you drive it around, it will see more white people than. So I'm encouraging some of you, start capturing data for self-driving cars. Go to release the data set. Okay, so now the question is, okay, so we have AI, we have machine learning, and some people also talk about deep learning. What is so deep? It's not that thing where somebody has said some wisdom to you and say, it's deep, it's deep, it's deep. No, that is not the deep learning. that is not the deep aspect of deep learning. Okay. The deep aspect of deep learning has got to do with the architecture. The architecture. So in classical machine learning, which is what I described to you, you put in data, you put in output, and there is a learning algorithm. So the learning algorithm is going to learn the intelligence, it's going to learn the patterns in your data, and that becomes the intelligence of the algorithm. So what you need to remember is that these algorithms are data agnostic, data type agnostic. What it means is that I can use the same algorithm to train voice recognition. I don't need to change the algorithm at all. I just need to change my data. And I'm throwing this as an exercise to some of you. You can work on simple voice recognition application. Let's say just recognize the numbers 1 to 10. Okay, so when I say 1, your AI should be able to tell me I said 1. When I say 2, it should be able to tell me I said 2. What does it take to do this? Create folders 1, 2, 3, 4, 5, up to 10. Start a recorder on your computer. Say 1, record and stop. Put it in the 1 folder. Say 2, record it, stop. Put it in the 2 folder. Get 10 of your friends. Let each one of them do the same thing. 1, 2, 3, 4, 5, 10. Okay? Get it. Group it properly. And these same algorithms that I'll be teaching you about, you don't change anything, just your data and the output. Ask the algorithm to train. It will train itself and it will come up with some intelligence. Then it will begin to behave. So the whole idea is you train it, you put it out there, and then you get to use it. That is the machine learning aspect of things. So there was a problem in expert systems which machine learning will solve. And the solution is that when the problem is getting newer instances, new things that you never saw in your data set, it's as simple as gathering these new data sets and retraining your model. Okay? If there are new things, you gather them. Let's say for some reason, some cats decide to give birth to cats that looks like birds. Then all of a sudden your cat detector is failing. Just go to the man whose cat is giving birth to baby cats. Take a picture of them, come and train, and all of a sudden those baby cats cannot bypass your trap again. But you can see that this is still a problem. We get to the solution. So in deep learning, what makes deep learning different from classical machine learning? It is the use of what is known as neural networks. Neural networks. Okay. This is how neural networks are organized. So you basically have what is known as neurons. And they have similitudes to the neurons in the brain. So we write code to represent a neuron. You will see all these things with time. Then you have your data. You put in your data. You put in your data. And through the magic of learning, so this is going to be your output. So this is going to be x1, x2, x3. x1, x2, x3 could be any feature of any data point. I will explain features to you very soon. Any feature of any data point that you throw to it. It could be pixels, it could be waveforms in audio file, it could be in actual figures. You throw this thing to this structure called neural network architecture. And through the mechanism of learning, which we will learn about, it will also be able to give you output as to whether something is a cat or dog, is something cancerous or not cancerous, is a self-driving car seeing a red traffic light or green traffic light or yellow traffic light? This is something that you should also be able to build. So for those of you who have been playing with Arduinos and stuff, I want to see some of you attempt to build that if you pay attention properly. Build simple AI that you can light a yellow LED and show it to it and to tell you yellow. You can light a red one to tell you red. You can light green to tell you green. And all of a sudden you've built.
I'll use a sensor.
Yeah. Look at him. He said he's going to use a sensor. So you get it. You get the point here. So when it comes to deep learning, it is the use of neural networks that distinguishes deep learning from classical machine learning. So whenever you hear people are saying, we are doing deep learning, then you know they are using the concept of neural networks. When they say we are doing classical machine learning, it is one of the algorithms that we'll be talking about that they are using. Any questions so far before we continue? Okay.
Hello, Edward.
Oh, yep.
Hey, please, will this recording be made available?
Yes, I think Eric is going to make that happen.
That one you have to come and pay to me. Okay, so just...
Yeah, especially after the money you got from the spraying machine you did for the COVID. We didn't see it up. So
I will insult Eric in the back door, but for you, we'll talk later.
Yeah, Pi.
Okay. So,
hello, Pi. Yeah, so I have a question, right? Yeah. So I'm kind of confused about something. Everything that you are describing, for instance, if I want to build a robotic system that is self-aware, right? I can actually employ sensors for it to use to know its environment without probably doing all this AI stuff, right? So when actually does the AI come in? Like, for instance, you were talking about this. You were talking about this light detection thing. So from physics, I know that each of the light wavelengths causes different signal levels with any photo detector, right? So I can actually code this to detect some thresholds and use it to estimate the colors, right? So when actually does AI come into the picture?
Great, nice question. So the light example I gave is a rather simplistic example because of our level of experience here. But you said you can use sensors and then you code. But you see, when the environment becomes dynamic and you don't want to have to go back to reprogramming, because it's not like you just put sensors and your robot begins to behave properly. The sensors are there to measure some physical quantities.
Yeah.
And the measurement of these physical quantities are supposed to affect the behavior of the robot. So if your situation is such that your robot is going to be used in a well-defined environment, okay? Something like if you go to the Amazon the warehouse, those robots that do packaging, they don't have any serious AI in it. You can use guided robots. You can put magnetic strips on the floor, and you can just put a magnetic sensor at the bottom part of the robot that if you sense the magnet and follow it. This one doesn't call for AI. It just calls for proper timing and proper sensitivity of your sensors, okay? But where the environment is dynamic, look at the self-driving car. How many sensors can you attach to your self-driving car for it to know that the traffic situation in Ashima is the same as the traffic situation in New York? In Ashima, when the traffic light is red, the motorist is crossing. When the traffic light is green, the human being is crossing. When you almost knock him, he will insult you on top of it. Where you and I come from, in Ghana, zebra crossing is not anything because we don't see zebras around. We are not a zebra. You get the point. So how many sensors are you going to add? So the AI comes in for adaptability, self-learning. The self-learning. And then sometimes AI comes in. So let me give you this rule of thumb to know when to use AI. You see, there are some things that we human beings, we know how to do them, but we can't explain them. If I ask you, how are you walking? It will sound like a stupid question, but I can turn it into a philosophy class for you this evening. That explain to me, how are you walking? Okay, I walk by moving my leg. How are you moving your leg? Do you know that something can affect somebody's brain, and with a proper working leg, the person cannot walk? You get a point?
Yeah.
So whenever there are things that we know how to do as human beings, but we can't explain how we do them, those things are candidates for AI. There's an experiment where they are helping the blind to see with their tongue. So they fix cameras on their foreheads. It's like a cap that there are cameras in there. And the feed from the camera is translated into some voltage on an electrode that is on their tongue. You see, in the brain, we have the visual cortex and sections for everything. It is even now that we are learning to see that the visual cortex is specialized for seeing, but with adequate training and time, the part where we use for taste can adjust to begin to see. So to these blind people, they put the electrodes on their tongue. So it's like the way when you put 3 volts on your tongue, it tastes different from 4.5 volt, from 9 volt, 12 volt to 25, where you meet your God. You get it? They taste differently. So they trim down these things. And as the electrode is on their tongue, as you are busy chewing pizza with your tongue, somebody is seeing with the tongue. Charlie, don't waste your tongue. Go. Somebody is seeing with the tongue. So this information goes to that section of the brain and it readjusts itself. So like when I follow the experiment, these people, the scene that they are seeing is not the way you and I are seeing, like I can see you, you are fair, you are this. No. But they can still identify. Do you get a point? They are seeing in another way, like another form of perception. So it's like if they see a ball, so the way the electrodes on their tongue,
they are testing images.
Exactly.
They are testing
images. So when they see football, the pattern of the electron like on their tongue is going to be different from when they see pizza. And this is really amazing. For anything that, as you are starting out, feel free to use AI for things that you can even do just to build your confidence and then your strength. But to know when to use AI is things that you can do, but you cannot easily express in code. I did one work with Mohammed. Mohammed, you remember when we learned pure learning? We were supposed to train a robot to go through a maze, okay? To go through a maze. Now, Eric, can you hear me?
Yeah.
I think his screen
is it a maze farm?
No, like maze, like we have used blocks to make blockages with roads and openings in them. And we were supposed to train a robot to know how to move from one point to the other without running into the walls. Trust me, if I give you 3 months to write such code, you cannot.
I'll use a sensor.
3 months. Yes, you use a sensor. But you see, fine. I get what you are saying. You put a sensor and you sense when is this. Okay.
That's all.
But then you can also let the thing learn on its own.
Yeah.
Look at things like space exploration. The conditions on Mars is going to be completely different from the conditions on another planet. So if you have to adjust your sensors to every planet, you have to first of all be on the planet and hopefully not die before you come back with data you will use to tune these. Okay? But with these self-learning systems, you can build the AI, put it on a robot, and put it there. At first, it gets there, it will struggle, but it will adjust, and you begin to see that whenever we are approaching a terrain where we don't have enough information, it is more safer to take a robot there, let it struggle the first time, find out patterns, then the robot teaches us the patterns. Then now we can safely go there. So that is when you know whether you have to use AI or not. I think I want us to close at 9 my time. So maybe let's do some 15 minutes more, then we can. So I'm going to also show you something in the browser. I have an organization of some courses that you can already start taking alongside what we are doing, especially when we are finished. You can see my browser, right?
Yeah.
Okay. So when you want to get started, it is very confusing. Trust me. This course, there is no course on earth better than machine learning with Andrew Ang from Stanford on Coursera. You take this course first. I'm giving you the guideline. You take this course first. The only unfortunate thing about this course is that he taught it using Octave. Octave is a programming language. It's a free version of MATLAB. So if you know MATLAB already, perfect. But if you don't know MATLAB, he will teach you Octave and then you will learn. However, the business is not even the Octave. This teacher teaches so well that if you pay attention, you can implement in Python or any language of your choice. So take machine learning from Stanford with Andrew Ang on Coursera first. It took me 4 years to finish this course. I started in 2015 in Ghana. I get to a point, then calculus will be like, bro, go back. You see, I'm so much excited. But you get to the point, you see that, Charlie, the calculus, and for me, I want to understand it, and Eric knows me. I want to understand the thing proper before I use it. So then I will pause, and this is a paid course. I was paying like 44 euros in Ghana. Then I will pause, buy a calculus book, learn it, then I will attempt it again. But the good news is that when I go and learn the calculus and I come back, I'm able to go further than I did previously. Then some other concept I didn't have the guidance like you are having. So I don't expect that you will attempt it multiple times. But take this course, it teaches great stuff. So it's going to start teaching you, look at all these things, welcome stuff, the normal, the types of machine learning, linear regression. Tomorrow we are going to do linear regression. It's going to be hands-on, and I will try to create similitudes between when you use it in robotics, when you use it in business and other things. Then he gives you a linear algebra review. So for those of you whose linear algebra knowledge has been used to eat gobe, you will do your matrix addition, multiplication, and those stuff. You see, it's unfortunate that we go to schools where they teach us these things without applications. So the guy who tops linear algebra in your class doesn't even know what he's going to do with it in real life, and yet he's sitting on gold. So he gives you the reviews. He spends like 2 weeks on linear algebra. Then you start linear regression in multiple variables, and then he teaches you the Octave programming language, logistic regression, regularization, and then neural networks. All these in MATLAB, if you choose to, or you can code them in Python. Very, very fantastic. Very, very fantastic. Then when you finish, before you attempt this course from him, this is what got me my AI job. Deep learning specialization is a bunch of 5 courses. The first one is neural networks, improving deep neural networks and hyperparameter optimization, structured machine learning programs, and then convolutional neural networks. That is when you want to build neural networks for computer vision stuff, then you definitely use CNNs. So when you hear CNN, it's not just TV. If you're talking to me and you say CNN, the first thing that will come into my mind is this before the TV CNN. And then we also have sequence models when you want to build models that understand human speech. Either you are talking or you are typing. So I can type something and then the computer will tell me whether the thing I typed is negative or positive. The first time I used such a thing was in Ghana for spam detection. You know, I was working at Haptel and we were selling bulk SMS and people buy it and they use it to send fake. Hey, do you know you have won this? Please text your phone number to this and then send a Momo to this to receive this. So I had to build a model to be able to detect these things before our SMS gateway will forward it. So when you send a message, the AI will decide, nah, this guy is a scammer. So before it reaches our gateway. So you see, there are sweet spots for AI. a very sweet spot. So Eric, this is a place where you can't use a sensor. Show me which sensor you can use to detect.
Oh, trust me, I am thinking about one.
Okay.
He will build one himself.
So until you create that sensor and you get your patent on it, we will use our AI model to determine fraud and non-fraud. Then show me a sensor that would immediately tell you that this is a cat, this is a dog. Okay. So you take this course, right? Now, when you finish in actual world, these courses are going to teach you with minimal use of libraries. And the reason is these are academics. They want you to understand what you are doing, because not until you understand something, you cannot manipulate it to do things that were not taught in the course. So they teach you the barest minimum at a raw level. So it sounds difficult, but after that stage, make a choice between PyTorch or TensorFlow. PyTorch is from Facebook, and it's the only thing I like about Facebook. It is a fantastically sweet library. PyTorch is like something I will teach you tomorrow. It's like NumPy. In fact, we can do some 10 minutes NumPy before we end. It's like NumPy. NumPy is a Python module for vectorized computation. And then they also give you the ability to do auto differentiation, the ability to calculate differentials. If you want to do AI, I'm not saying this to tell you don't show up tomorrow. I'm not going to do dy dx so that you run away. No, we will do our dy dx in code, and some code will do the dy dx for us. But it helps for you to learn. If you can see my board here, I have dy dx and several things on my board. So Python gives you vectorized computations plus the ability to calculate automatic differentiations. Then it leaves you to do everything else on your own. This is the only thing I like about Facebook. Or you can choose TensorFlow, which was actually the first AI library, Python mainstream AI library from Google. But PyTorch, people are smart. They saw all the mistakes in TensorFlow and they fixed it in PyTorch. So those who are using TensorFlow are those who unfortunately started with TensorFlow and maybe Google themselves. For all you know, even Google uses PyTorch and they are creating TensorFlow so that nobody can catch up with them, because PyTorch is very sweet, I will tell you. If you think TensorFlow is ugly, a Google guy called Francois Chollet have created a library on top of TensorFlow. And these are things I hate, like a layer on top of a layer. Then your understanding is too high level for you, but feel free to choose whichever one. I will teach you with PyTorch, by the way. So deep learning with Python. This is also a book. Eric, please remind me to share all my AI books with you so that you can copy it for the guys.
All right.
Guys, these are books I bought with money. Expensive, but I'm giving to you because I want you to read them.
$50 a copy. See me.
No, some of the books I bought for 240 euros. This is Mohammed. Ask him. I have shared everything with him.
I am going to give them $50 a copy.
So you decide which of these you choose and then stick with it. Okay. One more theory and then we learn NumPy quickly and then we close. So why is it saying I should join? I've already joined. Okay. You see my screen still, right?
Yeah.
Okay. So now finally, this is it. AI gave birth to machine learning, which gave birth to deep learning. Okay. So AI is bigger than machine learning. Machine learning is bigger than deep learning, because deep learning is like a specialization within machine learning where you are building models using neural networks. Machine learning is an approach to AI where instead of you codifying domain knowledge from experts, you let the computer learn on its own. Then AI is the umbrella. So it could be fuzzy logic, it could be ML, it could be deep learning, it could be expert systems, several other approaches are there. which you can use. But when people say AI nowadays, they basically mean machine learning and deep learning. This is what people say as AI, okay? Now, when it comes to machine learning itself, we have supervised learning. I'll just write the L because I'm lazy. Unsupervised learning. And then we have reinforcement learning, which is what I do with Mohammed. And by the way, I have a course on reinforcement learning on Udemy. So if you want to learn that, you can. It's just $10. You can buy it and then learn. Just search for Edward Pi on Udemy. You can find it. And please also subscribe to my YouTube, okay? I beg you. All right. What's the difference? Supervised learning is when you are putting in labeled data. So like I showed you, cat, you show it a picture of a cat and you tell it that it's a cat. It's like you are supervising it. The kind of learning that I'm giving you right now is supervision. You are supervising it. So you put in your data, you put in the label, and the model is supposed to learn patterns. So whenever you hear AI, think of automatic learning of patterns, automatic learning of patterns. It is more of pattern recognition. That is basically what AI is all about. Then we have unsupervised learning. Unsupervised learning, so under supervised learning, we have things like linear regression, multivariate regression. I'm being lazy here, forgive me. We have classification. These are the different algorithms that you have there. And surprisingly, all these different algorithms, you just need to change the data set. And you can see that at one point you are doing computer vision with classification. At another point, you are doing audio recognition with classification. That's the magic of these algorithms. The algorithms themselves are data agnostic. Data agnostic means it doesn't care which data you throw at it. The algorithm is going to work anyway, because at the end of the day, it is matrix that will show it. So as long as you can codify your data as a matrix, the algorithm doesn't care about it, okay? We have unsupervised learning. In unsupervised learning, we usually use it for what is known as clustering. So it's like you have a huge data set, and even you, the human being, you can't see any pattern in the data set, but you believe the computer can show you a pattern in the data set. You throw it at an unsupervised learning. So there is no supervision. It's like you are just giving it data, a bunch of them, then you ask the computer, tell me what on earth you see in this data. And to your surprise, the computer is going to show you some things. So for example, you are an e-commerce website. Then when people buy from you, you are storing information about them. All of a sudden, you have 100,000 records of people. Then the question is, what can I do with this data? Maybe you take people's name, their date of birth, their ethnicity, their age group, how much they are earning, whether they are employed or not employed, the demographics, where they stay and stuff like that. To be surprised, like to your surprise, you can throw this data at an unsupervised learning algorithm. It will tell you that all your customers who are under 18 and live in Accra, they like to buy iPhones. All your customers who are above 30 and they live in Accra, all of a sudden they have no taste for iPhone. They want to buy the most quality shoes so that when they buy one shoe, they can wear it until they are 50 years old. These are all hidden patterns that with your eyes, you will not see, but you show it to the computer and the computer is going to show you details that you don't know. And these are all mathematical. So in unsupervised learning, we usually do clustering, or what is known as dimensionality reduction. Dimensionality is S-lity reduction. So basically, you have some large data set. We also use it for compression. You have some data set that is wide. Maybe the question is, how can I reduce the picture of a cat to just 3 numbers? You see, a picture is made up of pixels, and if it's colored, each pixel has 3 numbers, the red, green, and blue component. So if you have a 100 by 100 pixel image, you actually have 100 by 100 by 100 3 times. those are the numbers that represent that simple picture. 100 by 100 red, 100 by 100 green, 100 by 100 blue. So multiply 100 by 100 by 100 by 100 by 100 by 100. That is the number of numbers that you need to represent a 100 by 100 pixel colored picture. The question is, how can I reduce these numbers to just 3 numbers? It is possible. It is possible. So you can use it for compression. You can also use it for what is known as anomaly detection. Anomaly detection. Anomaly detection. In anomaly detection, you observe the normal trend in some data. Then when there is an outlier, the model will flag. It's like I can build anomaly detection system on my credit card spending, the way I spend on my credit card. Then one day when a thief gets my credit card and buys something that is an outlier, the detection system will know. Like if I should put my data sets in such a model, it will know that I like buying books on computer science or Christian principles. I like buying courses. I like buying lab equipment and stuff. So the day you take my credit card and you sign up on a porn site, the anomaly detection system will say that, this is not Edward Pye. You get it? Or the day you take my credit card and you are betting with it, it will know that that is not me. That is what anomaly detection systems do. So yeah, for detecting outliers. So that is how, those of you interested in catching the fraud voice, this is what you need to do. So you study somebody's usage pattern. And this can also be used to determine when systems develop faults. Okay, so under normal circumstance, you know how much current your home is using. Then all of a sudden, the current reduces, the usage reduces, or it shoots. That is an outlier. Maybe your deep freezer has shut itself off. It has developed a fault, and your tilapia is getting rotten. For all you know, you don't know. You've not opened your deep freezer. But the day you open it, all your tilapia has become funeral. But with such a system, it will automatically detect those things, and then we'll show it to you. We have 1 minute before this call ends. When it ends, let's join again, and then within 10 minutes, we will close. So the next thing is reinforcement learning, which is my favorite, which is the kind of things Eric cannot do with sensors. Things that we can do as human beings, but we cannot explain how to do them. So those are the kind of things I've been doing with Mohammed. Self-learning systems, keeping things in balance, setting some thresholds and making sure you meet it. You are optimizing something. So the way we human beings learn is through reinforcement learning. For example, I don't think any of us here, our father intentionally taught us that fire is not good. They might have told us 1 or 2 times, don't go near fire. But the stubbornness in us got us close to fire. We got bent, then we learned that I don't need to get too close to fire. But we have also learned the good side of fire, that when we are cold and we stay a sufficiently far distance from fire, we can get some warmth, and that becomes a blessing. All these things our father and mother didn't teach us. We learned it on our own. So we learn through rewarding systems. You take an action and the environment rewards you. When the fire burns you, it's a punishment. And it is built into us to avoid punishment. So then we learn, what did I do? It's like credit assignment. What did I do to arrive at this situation? I touched the fire, then I got burnt. Okay, I was feeling cold. I got close and I'm warm. What did I do? I got close, but I didn't go too close that it will burn me. That is a positive reinforcement.